My dudes, this is Math Time with Mr. G, and today we're going to do some proofs with parallel and perpendicular lines. So I have been given that A and B are parallel, and that angle 2 and angle 3 are congruent, and they want us to prove that C, D are parallel. So as a reminder, our first one is A is parallel to B, and angle 2 is congruent to angle 3, and our rationale for that is given. And then I am going to say, instead of equals, congruent. That's our first step. Next, I'm going to say that angle 1 and angle 3, if we were just to look at it like this, 1 and 3, I'm going to say that those are congruent. So angle 1 and angle 3 are congruent. And my rationale for that is alternating interior angle theorem. So the measure of angle 1 and the measure of angle 2 are congruent because, remember, A, B, C, or A, B, A, B, A, B. So since angle 1 and angle 3 are both B angles, they're congruent. Next, I can say that the measure of angle 2 is congruent to the measure of angle 3. And that's because of our above statement. 2 and 3 are the same. So that way I can say if 2 and 3 are the same, my measure of angle 2 is congruent to the measure of angle 1. Because if 1 and 3 are congruent. My rationale for that is the transitive property. Just saying that if 2 is equal to 3 and 3 is equal to 1, then 2 is equal to 1. Next, I can say that the measure of angle 2 and the measure of angle 1 are corresponding angles. So I have line C and D with a line going through it, and if they are equal to each other with a transversal, I can say that those are corresponding angles by the definition of corresponding angles. So the definition of corresponding angles is my rationale. So there's separated by two lines and transversal, and they're congruent, they're corresponding angles. And then my last step is C is parallel to D. My rationale to that is corresponding angles separated by a transversal are parallel. Next, perpendicular. If one angle is perpendicular, then all of them are going to be 90 degrees. Pretty easy there for a proof. Next, we could use parallel lines and perpendiculars to find the distance of stuff. So let's pretend that these points aren't here and they give us these equations and they want to know what's the distance from these 2 points. So the first thing we could do is we could say negative 2x minus 2, this equation here. I'm going to set equal to this equation here. So 1/2 x plus 1. So by making them equal to each other, I'm saying when do these two lines cross? When are they at the same point they equal to? I'm going to subtract 1/2 from both sides. So then I get negative 2.5x minus 2 is equal to 1. Then I'm going to add 2 to both sides. Then I have negative 2.5x is equal to 3. Then I'm going to divide both sides by negative 2.5. I'm going to get x is equal to negative 1.2. So that's where they got negative 6/5. So if I plug that into my calculator. Next, I'm going to go back up to this equation and say y is equal to negative, instead of x, I now have a number for x. It's going to be negative 1.2 minus 2. So I'm taking this equation here, taking the x value, plugging it in for x. So y is equal to two negatives being multiplied, make a positive 2.4. And then minus 2, y is equal to 0.4, which is where they got 2/5 if I divide that. So that's how they figured out this point. They did the same thing with this point. They had this equation set equal to that one. So as soon as you find the 2 points, you can do our distance formula. And to remind you, our distance formula is y2 minus y1 squared plus x2 minus x1 squared. So y2 is negative 2. Negative 2 minus 0.4 squared plus x2 minus x1, so that negative will turn to a positive, squared. And then I could work that out in my calculator to figure out the distance. Other than that, be kind to one another, ask lots of questions, and think deeply.